Hello, geometry. So today we're doing, this is the last lesson for the week, surface areas of pyramids and cones. So, of course, I have my lovely pyramids and cones here. Here are my two pyramids that I have. And first, let's get a definition, which I don't actually have right here, but it is, let me look it up quick. It should say it has one base and one vertex. But I like to get it out of the book so it is perfectly accurate. All right. All right, so one base is a polygon, and all the other faces going to the vertex are triangles. And that looks a slightly blurry. Let's try this. Okay, so when we look at this one, the bottom is a square. But all of the ones going up to this vertex point, those are all triangles. Okay, so the name of this one is called a square pyramid because you go by the base. That's the base. Now this one, all you do is see triangles. But these three, actually it doesn't matter what way you lay it, that's a triangular pyramid. And in that case, they're all going to be triangles, but only in that case. Okay, so the base is just the one face, the polygon. All the other lateral faces are triangles going to the vertex. The vertex is the tip of the pyramid, where the triangles all come together. The altitude or height, which of course is, we use the cursive H, is the same in this one too. It's perpendicular segment from vertex to the base. And the lateral edge, or edges, I should say, I should put actually lateral edges, are segments with a vertex as one endpoint. So it's all these are all of the lateral edges. The base edges are the segments of the base, which is, of course, the polygon. You know, usually other than a triangle, unless it's a triangular pyramid. And the slant height, that's a new one, and it's with a cursive L. It's called slant height. It is different than the height up here. Okay, slant height. Think of the L in there is the L. The slant height is the length of the altitude of, get this, the triangular lateral face. Okay, so I threw a lot at you right here, but we are going to go over this right here. So the base is, of course, a what? 1, 2, 3, 4, 5, 6. There's a six-sided figure here. That's a hexagon. So the name of this is a hexagonal pyramid. Okay, this is your vertex. These are all your lateral edges, all the way through the back. The ones surrounding the hexagon are the base edges. The height would be from the vertex straight to the middle and perpendicular. That would be the height of the pyramid, which again is different than this. Pay close attention to this. The slant height goes through. Do you pick any of these triangles on the side? I'm just going to pick the one that to me looks easiest to see. And when you go straight through the triangle, that right there, the altitude of that triangle is the slant height. Okay, it's not the edge. It goes through the middle of the triangle. And what you're going to find is you're going to start making these right triangles right in the middle of it. So if you need slant height, you're going to be like, oh, do I have the height? Do I know this? And you can use Pythagorean theorem. Okay, feel free to re-listen to that if you need to. All right, so again, here could be another note card. We have the pyramid and we have our formulas. So notice it's half of the perimeter. Remember, P is the perimeter of the base. In this situation, it looks like it's a square. I think it's a square. Let's make it a square. There. So we will name this a square pyramid. Times the slant height. Okay, so the slant height isn't even drawn on here. That would be on this triangle on the side. That height. Okay, when you look at the surface area, it's of course the lateral area, which you did right here, plus one base, right? That makes sense, guys, right? We don't have two bases, we only have one. So you need to get the area of that base. All right, so let's try it. We got a square pyramid. It's right up here. Has edges of 5. I knew I was supposed to put 5 there for some reason. That's why. And a slant height of 3. Okay, so again, when I see slant height of 3, I put an L because that's slant height, and I circle it because then I'm like, okay, I got the L. The 5 is an edge right now, so I can't really label that yet. But let's look. We want the surface area. So I'm going to write my formula. Surface area equals LA plus B. So I know that I always need to come back over here. This is my main problem. I'm going to now jump aside because I need to figure out the lateral area. So I'm going to go over here and do that. So it is 1/2 of the perimeter. Well, if the base of one of these squares was 5, the perimeter is 5 plus 5 plus 5 plus 5, which of course is 20, times the slant height, which they gave you, which is 3. Again, these are all multiplied, so I can do them in any order. Half of 20 is 10, times 3 is 30. Okay, so I got my LA, it's 30. But I need my base, my area of my base. So I look at the base and I have to say, okay, what is it? It's a square. Okay, area of a square is S squared, which is 5 to the second, which is 25. I now have what I need over here. Okay, that's going to change. Sometimes the base will be a square, sometimes it'll be a triangle, sometimes it'll be a hexagon, or you have to do all that extra work to figure out, for a polygon. So needless to say, we're done with this problem. Its area, it should always be squared, and voila. All right, today's is a hint shorter. It's only 2 pages instead of 3 like yesterday. But tomorrow's going to be a work day. A little extra time to get caught up. Ask me some questions if you're struggling with anything, that kind of deal. All right, what's the lateral area of the hexagonal pyramid, round to the nearest square foot? Okay, so we'd get our formula off the other page. You can tell the problem that's going to come if you start using pyramid formulas for prisms, etc. So you got to really understand your shapes and locate and figure out what to use where. All right, well, I need my perimeter. So I'm going to go over here and do my perimeter. I see one side is 36. And so I am going to multiply that. I'm going to assume it's a regular too. I noticed it didn't say regular. Should put that in there so we know all the sides are the same. And I have 36 times 6, which is 216. Okay, so I've got a half times 216, and I need my slant height, and here's where the fun begins, guys. So look what I'm given. I'm given the height. That is not the slant height, people. But they also gave me this. So when I draw this in here, which is my slant height, I now have a lovely, lovely right triangle in there. Isn't that cool? So let me redraw it so you can see it right here. So I've got this is 42, this is 18 root 3, and you need slant height. What are we going to use, guys? That's right. Pythagorean theorem. 42 squared plus 18 root 3 squared equals L squared. Hypotenuse is always alone. So just to show you on the calculator to make sure you're punching things in. Can you guys see that? I don't think so. Okay. There we go. All right. So the 42 squared, simple enough, 1764. When you do this squared, the 18 gets squared, 324. But with the square root of 3 squared is 9. Square root of 9, which is 3, right? So the square root of 3 squared, the square and the square root cancel each other, and you're left with 3. So I've got 324 times 3. So 972 plus 1764. Square root both sides. And what did it say? Nearest square foot. So we're nearest whole number. So I'm rounding to that place. The number after it is a 3, so I just leave it, 52. But actually, halt, we're not done with the problem, are we? That's just our slant height. So I'm going to actually leave my number right in there. Do you see it? I didn't move it. And go up here. And just to make sure this is all accurate, I'm going to multiply it by 216 and divide by 2, which is the same as multiplying by half. And I can see the exact number here now around. So it's 5649.1. So it'll be 5649 feet. Okay? All right, let's talk about cones. Cones, right there. There's our lovely cone. Base, obviously, is always a what? A circle. The altitude and height is the same as it was on the other one. It's perpendicular segment from vertex to circle. Slant height. Okay, that is the same as the other one. It's not the height going up and down. It is the angle across here. It's from the tip all the way. It's sliding down the hill. Okay, that is your L. That is your slant height. So it's the distance from vertex to edge of the circle. And right or oblique is the same. That is our right one. It stands perfectly straight up. If it veered off to the side, it would be oblique. Okay, so there's my lovely picture. Actually, cones are pretty easy to make because this bottom part, if you don't draw a real circle, draw kind of an ovally circle, and the middle part is dashed, and then just peek it. It's pretty simple. Even I can draw it, and you know me with drawing. So here are our formulas. Again, they just came off of the other ones that we just used for the pyramid, except that we used the fact that the perimeter is 2 pi RL. Let me get that sheet of paper again. If we put in 2 pi r for perimeter here, the 2.5 cancel, and we're left with pi RL. Pi RL. And the lateral area plus the base, lateral area plus the area of the base, pi r squared. Okay, so it's just specific to a circle. So let's wrap this up. The radius of the base of a cone is 16. So I put R and circle it. Its slant height, slant, is 28. What's surface area in terms of pi? Leave it in there. So surface area formula, make sure we get the right thing that we need, is pi RL plus pi r squared. And all you need is the radius and the slant height, and you are given both. So let's plug them in. 16 times 28 plus pi times 16 squared. 16 times 28 is 448. 16 squared is 256. And now, remember, you have to do those separate. And now, because there's a pi in both, we can combine them. Just add the numbers. So 256 plus 448 is 704 pi meters squared. Aren't these fun? I love these. Okay, what is the lateral area of a traffic cone with a radius of 10? So let's draw ourselves a little picture. We got this good old traffic cone. Remember I said dotted, peek it. Pretty easy. Radius is 10. Height is 28. And what are we supposed to do? Oh, lateral area. Okay, so we only want that part. So lateral area equals pi RL. Okay, pi, we know the radius is 10. And so is the slant height 28? Beep, beep, beep. No, it isn't, is it? 28 is the height, is not the slant height. L is the slant height. So we just need to go and do our Pythagorean theorem again. So we have 10 squared plus 28 squared equals L squared. 100 plus, what is 28 squared? 784 equals L squared. 884 equals L squared. So L is the square root of 884. I'm just going to leave it in square root because I see it says round to the nearest whole number, so I don't want to put an approximation in here. We learned that, right? At least Dan and Jonathan realized that when we were going over the game, that when we're rounding too early in the game, then our rounding at the end of the game is off. So wait till the end, and I'm going to do it right now. So I'm going to do the square root first. 884 square root times 10 times pi equals. So I get 934.06, and it says to the nearest whole, which is the 4, where the 4 is. So it would be 934 inches squared. All right, there you have it. Have fun with these, and make sure you show real clear work with the homework. Okay, I'm going to be looking for work this week when you submit your stuff. All right, please contact me if you are having any trouble whatsoever. Take care. God bless. Bye-bye.